Unit 9, Day 3 starts our study of trig. So you don't have to say that whole word out, trigonometric ratios. You can just say trig. We're going to be doing triangle trig. So it's not going to be, if you have friends in AP Pre-Cal, or in any of the dual credits, they're doing a different kind of trig on a coordinate grid. We're going to be doing trig with a triangle. So it's all about different sides of different triangles. So let's discuss the names for different sides of this triangle. We know the first one, the hypotenuse. The hypotenuse is the longest side across from the right angle. So take a highlighter color, I'm going to use blue, and I want you to highlight the hypotenuse on the triangle that you are given here in the top. So it should be across from the 90-degree angle, that longest side. That's always going to be called your hypotenuse. Then we're going to name the legs more distinctly. So before we called the other sides the legs, we're going to call some of them the opposite side. The opposite side is the leg across from the reference angle. So notice my reference angle is highlighted as A. Across from it is this segment BC. That's going to be called our opposite side because it is opposite from the angle that I care about, from my reference angle. The next leg is going to be called the adjacent leg, which is a word that means next to. So if I look at the legs that are next to the reference angle, I have that this leg is straight up next to or touching the reference angle. So we have the three sides of our triangle. Let's label them with words in case you forget or didn't use colors. This is your hypotenuse, HYP for short, hypotenuse. Then across from the angle in blue is the opposite, OPP for opposite. And then in purple is the adjacent, ADJ for adjacent. So we have the three sides of the triangle given more specific names than we did earlier in this chapter. Instead of just calling it hypotenuse and legs, we have the hypotenuse, the opposite side, and the adjacent side. So our trigonometric ratios, or the trig ratios that we're going to learn about, are called sine, cosine, and tangent. Say those words with me. Sine. Oh, we're not awake today. Sine, cosine, and tangent. That is their names. That's how they're pronounced. But we have a shorthand for them when we talk about them in a ratio. This is sine. You see what the little arrow is? Do not say sin. That is my pet peeve. It is sine. It has an actual name. This is how you would represent cosine. Don't say cos. That is my pet peeve. It is cosine. Don't say tan. It is tangent. They have actual names. I need you to use them properly. But these ratios for sine, cosine, and tangent, the functions we're working with today, are comparing the different sides to the hypotenuse. In particular, sine is defined to be the opposite divided by the hypotenuse. Cosine is defined to be the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. So I'll give you a second to highlight with me because those are the same colors I used in my triangle. Notice every time I use the word hypotenuse, I've highlighted it blue. Every time I've used the word opposite, it's green, just like up here in my triangle. And adjacent is purple. These are the definitions I need us to know. And that's a lot of words to remember. So I've got a shorthand for you right here. It's called SOHCAHTOA. SOHCAHTOA reminds me that sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over adjacent. So all you really need to remember today for me, I would put a little bubble around this, is SOHCAHTOA. That is all of the vocabulary that you need. SOHCAHTOA. Sine, opposite hypotenuse. Cosine, adjacent hypotenuse. Tangent, opposite adjacent. Yes? So if you're stuck on a problem today, you're going to look at this cloud because it's probably going to help you figure out what you're setting up to solve a problem. So first things first, the first step in doing trig is identifying which trig function you need to use in a particular problem. So if you notice in the one we did for you, it said which trig function is represented. So I look at the angle that I'm given and decide what legs or hypotenuse I was given. I was given the opposite and the measure of the hypotenuse. Which of the trig function uses opposite and hypotenuse? That would be sine. If I'm looking for, in the second one, DF, that means I'm looking for this leg right here. I'm going to put an X there. What information am I given? Compared to this angle angle 50 degrees, angle D. I know the hypotenuse of the triangle. And what other piece of information do I know? Do I know the opposite side or do I know the adjacent side? Let me rephrase. Do I want to know the opposite or do I want to know the adjacent? I want to know this. Adjacent. It's touching this angle. So this is the adjacent side. Which of my trig functions uses the hypotenuse and the adjacent? Ooh, yes, but how do you actually say that? Cosine. So we would set up a cosine ratio for this triangle. We're not actually going to do that yet. We're just picking the correct trig function. That is the adjacent over the hypotenuse. Okay, now let's think about the third one. The question tells me to find PQ, which is here. So comparing what I know or want to know to the angle that I've highlighted, Q, what do I know? Well, what is that side called? Compared to my angle, is it the opposite, adjacent, or hypotenuse? Across from Q is number 5. So this is opposite. And then I know this other angle, or I want to know this side that is touching my angle. Is it the adjacent or the hypotenuse? Adjacent. So if I know that this is the adjacent, which of my trig functions uses the opposite and the adjacent? Tangent. Very good. So we would set up a tangent ratio for this triangle if we were actually solving it. Okay, I think we need a little bit of practice with this. So as flashcards, we're not going to get out whiteboards or anything for this, but you're just going to look at the board and answer in your head / out loud what you think the answer is going to be. Now that we can identify it correctly, let's see if we can actually use these trig ratios or what it even means to use the trig ratios. In number 2, numbers A, B, and C, we're going to find the trig ratios. So not only are we choosing whether we're going to use sine, cosine, or tangent, we're actually going to write the fraction or write the ratio. So if you look in the example we've done for you, we said this is the reference angle. This is called a theta, by the way. It's a Greek letter. It represents most angles. Angles in trigonometry are represented by Greek letters, typically theta, alpha, beta, or omega, but we'll probably use theta the most, or just an x. Compared to theta, we know the opposite and we know the hypotenuse, which means we'd set up a sine ratio of opposite over hypotenuse. So Ms. Caldera put 3/13 because that was the opposite number over the hypotenuse number. So we've set up the ratio. Can we do the same thing? All you have to remember is SOHCAHTOA. All right, we're setting up the cosine function. Cosine, what is the letters I would use for cosine? Cosine of theta is blank over blank. Look up at the top. What is cosine's ratio? Words-wise, blank over blank. Adjacent over the hypotenuse. Okay, very cool. So we want the adjacent leg to angle theta and the hypotenuse. What is the length of the leg adjacent to theta? Adjacent means touching. This is the side that's touching theta, the leg that's touching theta. So how much should I put in the top of this fraction? 11. What is the length of the hypotenuse? 12. Because the hypotenuse is always across from your right angle. It's that longest side. So the ratio for cosine of theta here is 11/12. So this would be your answer, 11/12. Let's do one for tangent. Tangent of theta, what are the two things I'm putting in the ratio or fraction for tangent? Blank over blank. Opposite over adjacent. Okay, so I just look at the triangle and find the leg opposite to theta and the leg adjacent to theta. What is the length of the leg opposite of theta? 271. That is opposite from it, so I'm going to put that number on the very top. What is adjacent to theta? 193. The two legs are the ones that we're going to use here in the correct ratio. So my answer here is 271 divided by 193. If you're having trouble picking the correct sides, it's okay if you draw angles across from theta. So I could draw, not angles, arrows across from theta and then adjacent to theta. That might be helpful for you if you're getting lost in where I'm getting these numbers from, or even labeling the sides with words. So now let's look at a whole big triangle here. In this whole giant triangle, it says find the following ratios for triangle RST. Write each answer as a fraction and as a rounded decimal. So this is where your calculator is going to come in handy. So we've done one of them for you. Using angle R as my reference angle, we see that across from R is 16. So everywhere there was the word opposite in my trig ratios, I put the number 16. Do y'all follow that color coding? I'll zoom in. I highly recommend color coding this for yourself. Adjacent to R is the leg 63. So everywhere in my trig ratios, the word adjacent shows up, or the A shows up. You see I've put 63. Across from my 90-degree angle, which is always my hypotenuse, is the number 65. So everywhere there was an H for hypotenuse in my trig ratios, I've put the number 65. So my three trig ratios for this triangle, sine of R is 16 over 65, or this decimal. Cosine of R is 63 over 65, this decimal approximation. And tangent of R is 16 over 63. I'm just taking the numbers from the triangle. Let's switch our reference angles now, which might get confusing on the same triangle. So let's actually draw a second triangle. You have a little bit of space here. We're going to draw the triangle again so we can relabel everything. So I'm just going to redraw this triangle right here. This is R, this is S, this is T. And then we have 63, this was 16, this is 65. The reason I'm having you redraw the triangle is because if you notice, the three things listed here that are blank for you to find use a different reference angle. This time, instead of comparing everything to R, we're going to compare it to S. So it's going to change some of our definitions. Sine of S would be the opposite over the hypotenuse compared to S, not compared to R. What is the length of the side opposite angle S? Across from angle S is what? 63. So that means that this fraction is going to be 63 divided by the hypotenuse. What's the hypotenuse here? 65. So that didn't actually change because, again, my hypotenuse is always the longest side. In your calculators, please, can you do 63 divided by 65? We're going to round to 4 decimal places as the problem states. So 4 decimals means you look at the 5th decimal and decide if you raise the score. This would be 0.9692.
Don't use alpha 1 equals.
Yeah, we want the decimal version. When you want decimals, don't use the fancy fraction or else it will just reduce the fraction for you, which is so polite, but not what we need. If we go on to look for cosine of x, the ratio for cosine, remember, is the adjacent over the hypotenuse. What side is adjacent or touching angle S? 16. So this is going to be 16 divided by my hypotenuse. What was the hypotenuse length? 65. All right, calculator moment. What is 16 divided by 65? Round to 4 decimals. we're rounding to 4 decimals, we look at the 5th decimal and say 5 or more, raise the score, 4 or less, let it rest. This one would round up to 0.2462. Now, last but not least, we're doing tangent of S. Tangent, remember, is opposite over adjacent. Compared to S, what is opposite of S again? 63. What is adjacent to S? 16. So in your calculator, 63 divided by 16. We'll keep all 4 decimals, so 7.5. But yes, if we were rounding to 3, you were correct. Interesting. So what do we notice about these answers here? Maybe specifically focus on sine and cosine in both types of angles that we did. What do you notice about these? You notice anything similar comparing these answers to these answers? They're kind of the same, right? Which ones are kind of the same?
The first one on the left and the middle one.
Yeah. So sine of R and cosine of S end up being the same number. What else is the same? Aren't these the same? Cosine of R and sine of S. So because we've changed our reference angle when we do both of these, what that means for us is that, and we're going to write this down, sine of R is going to be equal to cosine of S, and cosine of R is going to be equal to sine of S. This because these are complementary angles. These are cofunctions, which is a word I teach my dual credit classes. They're cofunctions. So because that these angles are complementary, we have a 90-degree difference in sine and cosine, which makes them equal to each other. Whole lot of complicated explanation as to why, and if you care, take dual credit or take pre-cal, and I'll explain to you why next year. Now, of course, it's not always going to be this simple. In these triangles, I gave you all 3 sides and wanted to know the trig ratio, which would help us eventually figure out those angle measurements, which we'll do next time. But on the back, go ahead and flip it over. We're actually going to be solving for missing sides, which means we need to be able to calculate different trig ratios in our calculator. There are really specific things you have to do to these yellow calculators to get them to work for you, so please listen. Your calculator, when you pick it up, because the class that I teach 8B is AP Pre-Cal, your calculator is in radian mode. What mode is it in? Radian. Not what we're doing degrees. So I need you to switch this calculator into the correct mode or else you will get all the wrong answers. So follow along with me. You're going to press mode on the calculator.
Everyone, please follow along, or else you're going to get wrong answers.
You press mode. You're going to scroll down to where it's highlighted the word radian, and you're going to select degree and press enter. When you do that, it should look like this that we've printed on your notes because it needs to have degree highlighted. After you've highlighted degree, you can go back to the home screen by pressing second mode, which is the word quit. So then it just goes back to the regular screen. So second mode goes back to the regular screen. Awesome. If we wanted to type in a trig ratio, there are straight up buttons for this. Right above the parentheses, commas, do you see the words sine, cosine, and tangent? Those are the buttons we're going to be using today to evaluate these different trig ratios. If you're getting a different number than me, your calculator is not in degree mode. And it won't be when you pick them up because the class before you uses radians. So you always need to check that your calculator's in degrees. In fact, when you second plus 712 to clear these calculators, it goes back to radian mode. So you have to switch it to degree every time you use it. Make sure you check. Okay, we'll make sure we actually know how to use these buttons. I want us to evaluate cosine of 52 degrees. So what we do is we press the cosine button. Then we type 52 because we're in degree mode, so you don't have to put the degree symbol. Close that parentheses and press enter. It'll give you a string of decimals. I want you to round to the nearest 10,000ths, which is 4 decimals. So for cosine of 52 degrees, we would write down 0.6157. Did everybody get the same number as me? Fabulous. Yeah. A classic mistake here is just being in the wrong mode. You don't know how many times it happens. Okay, sine of 18 degrees. So we press the sine button and type 18 and close our parentheses. We don't have to put the degree symbol. We're in degree mode. Round to the nearest 4 decimals. That means this would become 0.3090. Tangent of 37 degrees. You press the tangent button, you press 37, close parentheses. Oh no. And press enter. That means this would be 0.7536. Cool. Now here's the thing. This is why Miss Williams was making such a big deal about you picking up your calculator. Your phone calculators don't do sine, cosine, and tangent. So you do need to use one of my yellow calculators to do these problems. The follow-up question I can imagine is, Miss Quigley, when I go home, I don't have a yellow calculator. Great point. You can use an app called Calculate 84. It looks exactly like this. There's just ads, so it's kind of annoying. Or you can use Desmos. I specifically recommend using the scientific version of Desmos instead of the graphing version of Desmos, because the graph will show you something crazy when you do trig functions, because if you take pre-cal, you'll learn about all of that stuff. So go to desmos.com/scientific and make sure degree mode is highlighted. So you see the word DEG for degree. So if you're going home to do this, that's what I would recommend using, is desmos.com/scientific and making sure it's in degree mode. Yes?
It should default to that.
It should default to that, yeah. And if you end up on the graph mode, it should work for the most part, but I go to scientific mode, it's just easier. Way less distracting. Okay, let's actually solve some problems using trig. Now, again, this is my favorite kind of math, so even if you hate it, you gotta just smile and nod with me because I think it's so exciting. So when you're finding missing side lengths, the only option we had before today was to set up Pythagorean theorem and solve. Or maybe do one of our 30, 60, 90s, or 45, 45, 90s and solve. But those very specific things. With trig, you can use any right triangle. It doesn't have to be one of our pretty special right triangles. So we're going to label the given sides as hypotenuse, opposite, or adjacent, just so we know what we're working with, and identifying the sine, cosine, or tangent. We've already done that. You've been able to tell me which one we're using. Then we're going to set up the equation like a proportion. When we set up our equation like a proportion, we will cross multiply and divide and solve and then find x. So if we look at the example I've done for you, we've labeled the sides that we were given. Compared to the 10 degrees, we know the opposite and we want to know the adjacent. Opposite and adjacent is tangent. Do we agree? So that's steps 1 and 2. We've identified that we're using tangent. In step 3, we set up the fraction. Tangent of 10 degrees, because this is my degree, degrees go inside, is going to be equal to the opposite, 5, divided by the adjacent, which is a question mark right now, or x. If you notice, we've set up the equation, and if we create a proportion by putting tangent divided by 1, we can cross multiply and divide. 5 times 1 is 5. Tangent of 10 times x is x times the tangent of 10. You will divide by the entire tangent of 10. That's a whole number right there. So that we're typing it into our calculator, 5 divided by tangent of 10. And when we do that, 5 divided by tangent of 10, if we're in degree mode, we'd get 28.4. Let's see one of these live before we ask any questions, though, so we can refer back to it. Oh, here's another one done for you. Sorry, I forgot this one was also done. For this one, we notice that we want to find this side length, m. Compared to the angle we know, we want to know the adjacent. We know the hypotenuse. That's cosine. So we set up our formula. Cosine of 72 degrees is equal to the adjacent over the hypotenuse. Creating this as a proportion, meaning divide by 1 underneath the trig function, you cross multiply m equal to 50 times cosine of 72. At this point, you'd plug this into the calculator. The moment your variable x or m or whatever is isolated, that's when you turn to your calculator and you type it in. 50 times the cosine of 72, bop, question in the calculator, you'd get 15.5. Sorry, didn't mean for that.
Great time for y'all to practice putting it in. 50
Yeah.
cosine of 72. Put it in your calculator too.
Let's make sure we know how to type that in. It's a good point.
We're on the right mode. Still.
Ooh, yeah, that mode is important. Really, the trick here is being able to set them up correctly. Oh, that didn't stick. Let's try that again. Okay. Number 9 is the one we're going to do together. Cool. Which trig function do we want to use? The question means we need to decide, number 1, compared to our reference angle, what information do I have? What information do I want? This side right here where it's labeled 30 centimeters, is that an opposite, adjacent, or hypotenuse? Hypotenuse. It is across from the 90-degree angle, which means it is my hypotenuse. Now the x, the side I'm wanting to find, compared to the 50 degrees, is it opposite or adjacent? Opposite. So if that's the opposite, if I want to know the opposite and I know the hypotenuse, which trig function should I use? Yeah, look at the bubble. Which one uses opposite and hypotenuse? Sine. So we're setting up the sine function. We would say sine of 50 degrees, because that's the angle I was given, is equal to blank over blank, which should be the opposite, x, over the hypotenuse, 30. Once we've set up the equation, we treat it like it's a proportion. So I'm going to put divide by 1 underneath sine of 50 degrees. We cross multiply and divide. Crossing this side, this is x times 1, which is just simply x. Crossing the other side, it would be 30 times sine of 50 degrees, which straight up, just write that down. 30 times sine of 50 degrees. Do I need to do any more solving here, or is my variable isolated? I see some of us just straight up reach for our calculator. That does answer my question. Once the variable is isolated, you do just grab your calculator and go for it. We're typing 30 times the sine of 50 degrees, but you don't put the degree symbol, we're in degree mode. And we should get our value for x. Let's round to the nearest 2 decimals for this one. Rounding to the nearest 2 decimals, you should get that x side length, the one we're looking for, is 22.98 centimeters. Now that we've seen one live, like we had to do it, are there any questions about numbers 7, 8, or 9, which is really the bulk of what I'm going to need you to do today, is set up these missing sides and tell me some information. Are we feeling okay? Okay. Number 10 is a really cool application problem. Trig is when math gets like actually real life. They're not made up things. This is actually what people do to measure stuff. If you've ever seen somebody standing on the side of the highway with one of those machines, they look like they're just like kind of looking at stuff down the way. It's called surveying. Surveyors use trig to measure different like heights of roads and things like that. So this is actually applicable to different jobs you could potentially have in the future. But here's an application for you. It says a 12-foot ladder is leaning up against the side of a house. The ladder makes an angle of 62 degrees with the ground. How far up the side of the house does the ladder reach? Just like before in Unit 9, I highly recommend drawing a picture. So here's the house. Hee. Let's make it actually look like a house. There's my house. Don't laugh at my house. And then I have a ladder leaning on the side of the house. Okay. Well, obviously there's a ground here that makes a triangle between the ladder and the house. Do you see that inside triangle there? We've got a 90-degree angle created. So this is a right triangle problem. It says the ladder makes an angle of 62 degrees with the ground. So I'm going to put my 62 degrees between the ladder and the ground. Do y'all see why I picked the 62 degrees there? It's called an angle of elevation. We'll get there eventually. How long is this ladder, by the way? Where should I put the 12 in my triangle? What is that called? Starts with an H. The hypotenuse, very good. So this is going to be my 12, that should be blue, 12 feet. We were given very little information here, which is why trig is so cool. With just these 2 numbers, the angle of elevation and the length of the ladder, I can figure out how far up the side of the house the ladder went. I want to know this length right here. Which trig function am I going to use? Sine, cosine, or tangent? Ooh, why sine? That's correct. Very good. Sine uses the opposite and the hypotenuse, which is what I want and what I know. So we set up our function. This is going to be sine of the angle, 62 degrees, equal to the opposite, which I don't know, so I'm going to put an x there, over the hypotenuse, which is 12. At this point, once I've set up my ratio, I make it a proportion, I cross multiply and solve. So I put the divide by 1 underneath sine of 62 degrees, and I cross multiply and solve. And by I mean you. I want you to finish this problem for me. We've got you to the point where it's all set up. I just want to make sure we've got the algebra to solve it. Let's round to the nearest tenth, which means 1 decimal. When we cross multiply and divide here, oops, I typed in the wrong numbers. When I round to 1 decimal, so the nearest tenth, we should get that x, or the height of the ladder leaning against the wall, is 10.6 feet. So this height against the house is 10.6 feet. Did we get 10.6 in our calculator when we did it? Very good. Last problem on our notes for today. Again, it's going to emphasize how little information you can be given and how much information you can solve about a triangle, which is why trig is so cool. If you look at this problem number 11, we were only given the angle and the what? A hypotenuse. Interesting. So by only being given the hypotenuse and the angle, can we find the values of x and y? Well, if we notice, x is the side opposite of my angle. So if I'm looking to solve for x, which trig function am I going to use to solve for x? Sine. So let's set it up. You guys tell me what to write down. It would be sine of what? Sine of 26 degrees. I guess I should use my colors. 26 degrees. Equal to what over what? X over 14, because it's opposite over hypotenuse. We cross multiply. X times 1 is x. Sine of 26 times 14 is 14 sine of 26 degrees. At that point, I'm done solving. Beep, beep, bop, calculator question. We would get that x is going to be equal to 6.1. We don't have units. 6.1. And that is the green opposite side. But this question goes on because it doesn't want you to just find x. What does it also want you to find? The x and the y. Okay, so look at y. Compared to the angle we know, what is y? The adjacent. So if we have we want to know the adjacent, and we have the hypotenuse, which trig function am I going to use to find out that side? Again, I want to know adjacent, I know hypotenuse. Which one uses adjacent and hypotenuse? Cosine, very good. So we're going to do the cosine of 26 degrees, same angle, we didn't switch our angle, would be equal to the adjacent divided by the hypotenuse. Can you guys finish this one for me, please? I want you to find that length y. When you do this problem, the thing you should type in your calculator is 14 cosine of 26 degrees. Again, you don't have to put the degree symbol because We're in degree mode. What did you guys get? 12.6. I agree. That is my adjacent side, so that is y. Look at that. With only a hypotenuse and an angle measurement, we found all three sides. Trig is really cool, and it's really simple to use. I find it easier than Pythagorean theorem in calculations because there's less I'm typing in my calculator with the fraction or with the square roots versus the sine, cosine, and tangent. So I prefer trig than some of our other right triangle stuff. Yes, sir. Yeah. Any lingering questions for today? These are my 3 basic trig functions. So we're putting in angles, getting out sides. You're looking for sides today.